Hello, everybody. Welcome everyone to the second edition of the FlameCon. Apparently, our timer bugged again, but I guess third time is the one that we got that did it right. I'm very happy that we have all these awesome people here. We have the whole team on this edition and a special guest. And we already introduced ourselves on the previous, but let's introduce again so everyone who missed the last one know who we are. I'm Eric. I'm from the Flame team. I have been working on Flame for 2 years already, and that's it. I like to program a bunch. I like the game dev, and that is it. You may know me on our community by Captain Black Pixel, and I guess that's it. All right, go you, Lua. Introduce yourself. Lua.
Hi, I'm Luan. I'm the original creator of Flame, so I have been contributing for several years, and now it's been getting a lot easier actually with the help of all these wonderful people here that you are seeing and everybody else in the community. So I'm really excited for this second edition of FlameCon. I'm really glad everybody is here, like sharing cool things and learning about Flame and about game development.
Awesome. Go, Hannah.
Yeah, I'm also one of the maintainers of Flame. Also, I've been messing with Flutter for a long time. So yeah, Flame brought game development into my life, and it's really awesome to be on an awesome journey. And let's see what Flame has for us in the future.
Excellent. Go, Lucas. Tell us about yourself a little bit.
Yeah, I'm Lukas. I'm from Sweden. I'm also in the Flame Engine team. And I think my first PR was accepted maybe 1.5 years ago. And then last half a year or so, it's been a lot more work done and locked up in Corona. Yeah, that's pretty much all from me.
Great. Now, Josh, on the newest member of our team, tell us about yourself a little bit, man.
Yes. Hello, my name is Jochem. I'm from the Netherlands. I've been, playing and working with the Flame engine on my own for almost a year now. Done a few contributions, and you might know me from the community as Wolfenrain, or for short Wolfen, if you can't pronounce my name. And I'm mostly known for experimental rendering techniques, like the Pseudo 3D rendering that David's going to talk about soon as well. And since yesterday, I've been part of the Flame team, and I'm happy to be here.
Welcome.
Thank you.
Awesome. David, you want to talk about a little bit about yourself?
Sure. So I'm David, game developer. I'm in the US. Some of you might know me as the developer of Tomb Toad, which was recently released on the App Store and Google Play. Thanks so much to this awesome team. I was able to use Flutter and Flame to produce that. And I'm going to be talking about the fairly, well, I shouldn't say novel, but interesting pseudo 3D effect I was able to achieve with that.
Awesome. Thank you a lot for accepting the invitation to present.
Absolutely. Thank you for having me. Pretty cool.
Awesome. We look forward for your presentation. So for the first presentation, I'm going to leave the stage to Lukas. He's going to present a little bit about Flame's Effects API. So that's it. The stage is all yours.
Thank you.
Just share it.
All right, let's see here. There we go. Apparently, I'm not allowed to share my screen myself, but Eric has to do it for me. Yeah, so I'm going to start with a much simpler topic than we have for the second presentation. I'm going to talk about our effects API, which is basically an effect is something that you can do to a component that is added to the engine, and that is something that is happening over time to that component. It can be pretty much anything, but all the effects that we have so far, they are on the position component, so they all have to do with how it looks like and where it's moving and stuff like that. But in theory, you could do pretty much anything that you want to do to effect that is happening over time with a curve. Right, and these are the effects we have. So like a move effect, just move your component from one part of the screen to another. The scale effect, you just make it larger and smaller. The rotational effect, so you can rotate your component. The sequence effect, so that you can put several of these other effects or another sequence effect after each other and handle it as one effect. And then a combined effect where you take two effects happening at the same time. So like, for example, you want to move and scale at the same time. And yeah, most of my presentation is going to be some improvised live coding. So let's see how that goes. I guess you will have to pull in my screen again, Eric. Ta-da! All right, so this is what we're gonna start with. If you have done a Flame game before, you have seen this this type of structure before. Or if you have haven't done it on version 1, it might look a little bit different here, but it's almost the same. So we're just gonna have a game that extends the base game and has the tap detector mix in so that we can recognize taps on the screen. And we just load an image here, which is going to be the Flame logo, and we put it in the center of the screen and just add it to the engine. So this we won't have to look at anymore. We can just show how that looks like. Run that. And open another tab. And yeah, here it is. You just have the logo in the middle of the screen, and it's not doing anything yet. So yeah, if you're making a game, you usually want to have some form of interaction or something happening to your components. So that's what we're going to show now. Back to the editor. So we have our sprite component here, which is loaded by the onload thing, which is the Flame logo. And then here we have our overrided onTapUp method, which will recognize when the user have left the screen with their finger. So to add an effect to a component, you simply just, like a sprite component is called Flame, so we just use add effect here, and say that we start with one of the simplest effects, the move effect. We add that to here, and that takes a path. But to start with, you can just use a single point, so you can just write the vector here like this, and say that you want it to go to like position 100, 100 on the screen. If you haven't used version 1 yet, you might not recognize the Vector 2 as much, but in version 1 on Flame, we're using Vector 2s almost everywhere. So if you don't know them, it's a good thing to get used to. But right here is if we want, since we're doing it in this on tap up method, we can just use something a bit more interactive. We take this the position from the event that we got back and convert it to a vector 2 and send it in there. And then here we can choose from either having a duration, so that will be like if I press somewhere on the screen, it will take that many seconds for the component to move there. But we can also have, so then if I press like very close to the component, it will go slower, and if I press further away, it will go faster. But then we also have the speed argument here, which it will be a static speed wherever you press on the screen. So we can show that. Let's say we have a duration of 2 seconds here. And then we run this. And refresh this one. And now we can say I'll tap here. And now it doesn't move. That's interesting. Why is that? This is like the classic thing that happens when you're streaming, but not when you're not streaming. Check encoder. I know why. We're running the wrong code. I had like a backup file if I managed to delete the other one or something, and clearly I ran from that one instead of the one that I was supposed to run. And now it just has to... Oh yeah, and as you can see here, I'm not running it on a phone because or on a device emulator or something. I'm just putting it in the Flutter web because it's much easier to do with the streaming, but you could easily run this on your phone or on anything too. Okay. Okay, please let this one move now. Yes. All right. So there you can see that it moves. We can just move it wherever we want. So that's pretty simple, right? I can go back to the code again. Right, and what if we have a few different options here that we can add. So for example, if you want it to go back to where it started from, we can add is alternating. So that means it will first go to the or do the whole path that we have given to it here, and then it will go back to where it came from. So we can try showing that then. It's here, goes there, and just goes back. Simple enough, right? And go back to the code. And maybe we want to, like, we don't want that to stop. We want it to do that all the time, like just go back and forth, back and forth, back and forth. Then there is it's infinite argument that you can put in. And if we put that to true too, we can show what that looks like. It goes back and forth, back and forth. And so if I, yeah, it's basically that for the move effect. Oh no, there's one more thing we can show for the move effect. And that is, what if you don't want it to move by a linear curve? Then you can add a curve for it too. And say, I don't know, bounce in, bounce out. That sounds pretty fun. Let's try that one. And let's remove the is infinite. Would be really handy if you could share two windows at the same time, not having to go back and forth. So here you can see that it's not moving with a like linear curve to it. It's going a little bit faster and then it slows down. And it goes back. Yeah, so let's try out some of the other. First, we can show how it is if you add multiple vectors to the path. So if we break this one out and put it up here, we can have, first it goes to the position that we tapped, and now we can go to like position minus minus 200 pixels. Yeah. And then to, I don't know, just the static vector, maybe 500, 500. Right. So if we press somewhere here now, yeah, right now we have a duration is only 2 seconds for it to move all over this place. So if we put it a little bit shorter here, maybe. Yeah, you can see that it's like following the path that we have set for it. So you can do pretty cool things with that. Right, now let's go over to show some of the other effects that we have. All right, so showed the move effect there, right? We can remove everything in here. And we can go ahead with the rotate effect. Let's see what that takes. Takes an angle, and the angle is in radians. I don't know, maybe position point X, so that it is not the same all the time. We'll just take something from what we have. So since one whole lap is 2 pi, we can very rough estimation of pi here now, so we don't have to import anything more. And then, so this one we can do the speed on, and that is in radians. I don't know if you pronounce it like that in English, but radians per second. So let's do like 0.5 or something. Now we can add a curve here too, just like with the other one. Let's choose something weird that I've never tried before. I don't know, elastic in, let's try that. Right, let's hope it rotates now. Okay, it rotates very slowly. Ah, okay. There we go. So elastic in seems like it goes like a rubber band a little bit back and forth and then finishes. That's nice. Okay. And just like with the move effect, you can add duration here instead of speed, so that it will be how long the whole effect should take, because sometimes it's easier to use that than to use the speed, and especially if you want to coordinate different effects happening in different places in the game or something like that. We can show the scale effect, I guess. And what does the scale effect take? Size, I guess, yes. So we can go down and check like or we can get, say, get the size of the current size of the component, and then we'll make it, let's make it a little bit bigger then. So let's make it, I don't know, 300. And let's, I don't know, we can use this alternating again maybe, so that it first grows and then it will shrink back to what it started as. And then let's add some new curve. Okay, let's refresh that. Okay, let's see if this works. No, it doesn't. And maybe someone noticed, but we forgot to put speed or something in there. So this one probably crashed if we're looking in the console. So I'll go back to do that. Add either speed or duration is needed. Otherwise, it has no idea like how long should it take for it to reach its end size. Let's do a duration of 3 seconds. Oh no. Okay, let's hope it works now. Yeah, here we can see it growing. And then going back again. So we can see it following that curve too. If the curve was called ease in exponential, so I guess it goes very slowly in the beginning, faster and faster, and then it follows the same curve on the way back. All right. Let's see. What have we done? We've done the move effect, we've done the rotate effect, and we've done the scale effect with it now. So let's do the sequence effect then. Then we can use this scale effect again. Let's put that one here. Maybe scale or something. And then we can use the move effect in. Well, let's take the position that we got in there. Duration of 2 seconds. And we can let this one follow the linear curve as it has as default. So you don't have to add a curve. In the normal case, it just has a linear curve. If you don't want that. And then we can make the sequence effect there. Let's see, what does this one want? It wants a list of effects. We should probably not name it effects. Probably not look good. List of effects. So let's make it scale first and then move. And then here we can also add is alternating or is infinite, etc. So then yeah, we can do that. And we can also add a curve to this one. Oh, maybe we can't. Apparently not. So let's try that out. Oh yeah, and for this one you don't need to have a time, because this one will be the time of if you put your effects in sequence, it will calculate how long it will take for the full time of this one. So this one, I mean, since this one is 3 seconds and this one is 2 seconds, the full scale effect will be 5 seconds. It makes sense, right? Okay, let's see if it works now. It scales first and goes back, and then moves and goes back. Oh yeah. And since our scale effect was alternating from the beginning, it already did that alternation. So that one didn't have anything more to do since it's already back at its start position. But the move effect didn't have its alternating on it. So that one you can see moving back now, since the sequence effect was alternating. And yeah, then we can go on with the combined effect. This one takes effects too, and then it takes an offset if you want the effects not to start at the same time. Then you can right now you can only set one static offset, so all the effects in there will be, for example, say that you have an offset of 2. Then the first effect will start, and then it will wait 2 seconds until the next effect starts. But there can be some time overlapping there if you want to. But let's try it without any offset first. Let's have it, yes, like this. So yes, do the scale and do the move. Okay, let's see if it works. So there you can see that it grows at the same time as it's moving. And then you can, so if you would want it to move back and forth there all the time, you can just put is infinite on the combined effect, and we'll just go back and forth with that pulsating thing. You can probably come up with quite a lot of cool things to do with that in a game. Yeah, I think that is everything. Oh, one more thing. So if you want to integrate the effects into your game, it can be good to know when an effect is done. Oh, I should move back to the code so you can see what I'm trying to show you. Then on all effects, you can add an onComplete function. And this lambda will just run when the effect is done. So then you will know, for example, this thing has moved over here now. Then this other thing should happen, which is very handy to do. This infinite here. Let's add a rotate thing so we'll have everything running here. Meanwhile, we take some questions. Okay, let's try that. Oh, I have to add it to. That's too much at once. Where did the rotation go? Or we were just very unlucky and got a very small rotation. That's strange. Did I forget to reload this one? Probably did. There we go. Now it's rotating too. Rotating and growing and doing whatever. All right, I think we're ready for some questions, Eric.
Awesome. So if everyone has any question, just drop in on the chat and I can showcase and read it to Lukas.
And I will put up the code that we used here in this repository.
Nice.
If you want to check it out.
Any questions?
Everything was crystal clear, so no
Yeah.
one had any questions. Or no one understood anything. They don't know what to ask.
Either of them.
Yeah.
Well, all right. How about transparency?
Good question. Yeah, so that is a perfect example of an effect that you could make with the effect system. But or transparency or changing colors or something. But right now we don't have it. But you can easily build it on top of the effects engine. It would probably be, I don't know, 30, 40 lines of code. It will be quite simple, or if even that.
Yeah.
Because it gets all the logic from the engine underneath.
Yeah, we did have planning some like painting effects per se, but at the moment I think we just have like position components, right? So just things
Exactly.
that affects position or the size of the component. So for now, that is building on Flame right now.
Yeah. But they just extend effect and you can do anything. The possibilities are endless. And then you will get all the calculations with the curves for free too.
All right, got another one. How do effects between components work? For example, collision caused by the effects.
Yeah, so that is up to you, I guess, because we don't really have any collision handling built in for the position components. It is only built in for the physics engine that we're using, Forge 2D. But you could you have a pause thing on the effects or a remove thing on the effects. So if you detect a collision, you can just remove the effect if that is what you want to do, or add another effect on the collision. That is more up to the implementer.
Great. All right. Any more questions? If not, I'm gonna go to the next one. All right. I think that's it. If anyone has any more question, where everybody, Lukas, is on Discord too, so feel free to join there and ask questions there, and we can ask later too.
Exactly. Yeah. Our Discord is great. It has a very nice community vibe to it. So if you're not in there, you should definitely join.
Yes. All right. Thanks a lot, Spyron. Thanks. It's a
Thank you, Eric.
Awesome. So now I'm gonna call Luan. We are gonna have a little presentation from Luan between the talks. Luan's going to present a little bit about the work that we are doing at the moment on Flame, about the first stable version of Flame, the first V1 version. So I will not spoil anything. So the stage is all yours, Luan. Feel free.
Thank you, Eric. Let me share my screen here. Okay, so this will be really quick. I just wanted to talk a little bit about V1 or 1.0, which I think it's the topic that we're all very excited about. And yeah, but before that, I want to talk a little bit about history. So as I was saying in the chat, we came a long way, right? We started a long time ago, and it's been so good to see this little project growing so big and with the help of so many people from the community. I went to GitHub and I actually looked at the first commit in the repo. So that's October 21st of 2017. So that's like about 10 years ago, basically. I just started this project. I had no idea. Like, I normally just put everything on my GitHub. If you go to my GitHub, you see like a lot of random stuff and projects like have started, and some projects, some like things that even if I don't think it's something like other people use. I just like put it on GitHub. And Flame started just like as my thing that I wanted to make a game in Flutter. And yeah, and a cool thing that I realized when I took the screenshot is that, so this happened on October 21st, and then suddenly 3 days later, we got our first PR, which was just formatting tweaks, but that was like really cool to see, and it shows how great this community is, basically, how we are together and helping each other, and now Flame is something much bigger, and there is like this whole ecosystem of people helping out, making games, making packages, making components to help, making PRs, helping each other with game dev questions on our Discord channel and everything. So yeah, I just wanted to share a little bit of history, but let's actually get back into topic. So why 1.0, right? What does that mean? So since we launched, of course, we started with a 0 point something version, right? That's pretty standard when you start something. And as we got bigger and bigger and people start actually using Flame and releasing full games that are readily available now in the stores and everything, people start asking, are we ready for production? Are we 1.0? And one thing I wanted to say, like, I really feel Flame is totally ready already. Like version 0.28 or whatever is the latest, known 1.0. But we wanted to take this opportunity, like this big thing, which is launching the first, like 1.0, the first like full number version, to actually make some changes. And we have been talking a little bit about all those changes. You've probably seen the article where we announced the first FlameCon. I also talked about 1.0 and our goals. You've probably seen a lot of discussion on Discord, on our issues, on our PRs about things we're changing. And a thing I want to say very clearly right now is that we're not launching 1.0 right now, just to get our expectations right. But I think we might be soon. It's still under works, but I think most of the changes the massive breaking changes are in. And now it's more about tidying it up. And that's what I'm going to talk about. So we already have two release candidate versions that we shared. So the last one is release candidate 2. That was a little while ago. And we are very soon going to launch the release candidate 3. And I believe this version will be pretty close to V1, to whatever we're going to do. So recently we merged the V1 branch to the develop and master branches on GitHub. So that just shows our commitment that we're actually going to do the flip. We still have a branch for the old stuff. So if there's like a bug on version 0.28, we can launch a new like patch version for that. But other than that, we're focusing on developing V1. And release candidate 3 will be launched soon. And I don't think there'll be any major changes after that. Of course, there'll be small changes, maybe some renames, even breaking changes, but nothing super big. So I think we're really close. And you can use the develop branch right now if you want the real bleeding edge. On pub, you can point to the develop branch directly. Of course, be aware that, anytime we can break things. But yeah, I think we're close. And I wanted to share some of the bigger changes that are coming on V1. But first, let's talk a little bit about like overarching goals for our projects. So I put in something here, like some pillars that I think we should keep in mind that we always try to adhere to when building V1 and moving forward. And Flame is basically an open source, so free, community-driven, built by the community, for the community, simple. So simple here doesn't mean that we don't have a lot of features, because we definitely do at this point. We have a very big assortment of things and features and integrations and stuff. Simple means they're all like easy to access and to use and to opt in. And that also ties to modular, which means everything is like neatly packed into a container. You can pick and choose which modules you want, and Flutter Game Engine, which is Flame. So this is our pillars. This is everything we're thinking about when talking about V1. And so what are the major changes? Well, I looked at our changelog, and as you can see, it's quite big. There are a lot of things that I've been working on, and this is just the overview, right? We added like a lot of infrastructure stuff as well. So I tried to break that down into 7 major changes, and I don't have a lot of time here, nor do I want to go into very deep details about each one, because those might be other talks and other possibly future topics that we might cover. But I just wanted to highlight, like, what do you need to know? I want to migrate my game. Like, what are the key things that I need to know, be aware of? And also why we're doing those changes. So the first thing we did was the package split. So that's something we already talked about in some detail in the article, and how we want to like break down. And basically the goal here is to have the Flame package. It's very like dry and simple. It has no dependencies. It has no native code. It's really just the engine. And then everything else is going to be split up into packages. So here I drew this is a fairly badly drawn diagram of what Flame is today, as you can see. I mean, today, we can say today it's V1 already, right? So this is the past already. And you can see some things are packages, like the Flame Gamepad package is separate. But a lot of things are inside, like Box 2D. It's something quite specific, like it's a physics engine and was built in. So everybody that had Flame kind of inherited this, and they couldn't you don't need to use it. It's not like it's not like mandatory, but you had a dependency. And so our next structure, Flame, is basically isolated, right? And everything, including audio, is a separate package. And we have this kind of structure with the Flame_star. So, for example, audio players is the package I made for playing audio. That has nothing to do with Flame. It's an audio player in Flutter. You can use it in your apps. Has nothing to do with Flame games or game loop. And then to bridge those, instead of flaming depending on audio players, there is a Flame audio package. And that's basically a set of helper functions that will make it very easy to use audio for a game context. So it kind of bridges audio player into Flame in its own package. Same thing, we had Box 2D, which now has been renamed to Forest 2D, which is our own take on Box 2D. But still, even Forest 2D doesn't have anything Flame in it. It's just a physics engine, right? You can use it with Dart. You can use it without Flame. And then we have Flame Forest 2D, which is bridges. So basically, your game would depend on Flame and then a list of Flame_* things. So probably Flame audio, I would guess, like most games, right? But then you want a physics engine, depend on Flame Forest 2D. You want tile, depend on Flame tile, and so on. And now everything is nicely like tidied up. And then you can have higher level packages like Bonfire, which you all know from the previous FlameCon, which will depend on a lot of these building blocks, and then it will be like a whole like framework for building our RPGs. So that's the first change. But wait, there is more. Not only we are splitting the packages, we're improving the packages. So some things that I wanted to shout out. We have been doing a lot of work in audio players. It's a very challenging package to maintain for sure, because it definitely has like the most native code in the Flame ecosystem. And yeah, I recently migrated to Swift and Kotlin, so that will make our lives much easier. And we have a lot of things planned to like improve and try to work around some bugs and fix stuff, provide some better APIs. So a lot of work in audio players. We also did the Box 2D to Forest 2D rebranding and refactoring. So Spidon has been working a lot on this and making sure the APIs we use for Box 2D are really better suited for a Dart ecosystem, because they're very based on their C++ version, and not everything translates as nicely to Dart. We added more tiled features in the tiled and Flame tiled packages, and much more. So that's the first thing. Second thing, I'll go very briefly. It's a total revamp on the effects. I mean, we just saw that on the previous talk, so I'll just pass right to that. The third major change was the vector 2. So you all might remember that we have a position class, right? And that basically represented a vector. The reason that existed was Flutter has a lot of classes that represent pairs of doubles, right? It had offset size, and they had different meanings, but neither of those classes really truly represented like a maths vector. And they had all the vector operations like that you expect. And for a game perspective, that's very, very much important. So position kind of bridges that gap and allows for easily converting one to the other. We realized that we were reinventing the wheel, right? There is already a library called vector math, and that provides the vector 2 class, which is basically all we wanted. So we basically just added a lot of extension functions on top of that to add a few things that were missing for us. Sorry. And also to allow easily converting. So you can easily, let's say you have an offset, but you need a size. You can easily convert it to vector 2 and then convert it to size. And with this comes a lot of breaking changes because we changed everything on Flame to be consistent in use vector 2. So as long as you're inside your game, everything will be vector 2. It will all work. It even has operator overloading, so we can sum it up. You can like do all the things you expect from vectors, all the operations that will make our lives much easier when dealing with 2D space in general. So fourth thing, sprites and images. So this has been a major overhaul. This is probably one of the things that will require the most like changes in your existing games. And again, I'm not going to go into too much detail because I think this has been already been longer than Eric has allowed me to. So you can go into GitHub and check it out. But basically, the way we load sprites and images and the components has been changed. So now it's much more clear what's going on and whether it's loaded or not. We don't have those like unloaded components that were a source of confusion, like they were added to the game, but they were not yet loaded. So now everything is much simpler. And also the methods for rendering are much simpler. And the fifth thing is the long-lived composite component. It is dead, but we actually upgraded it. So now basically we decided to promote that to a first class citizen. So everyone now has children. Well, not everyone. So basically we had the component, the master like hierarchy base class, and then immediately below we had position component, right? Basically we're opening a gap and now we have base component. And what base component is basically components that can have children, right? So if you don't want this, again, totally opt in, you can use the base component, the topmost component, and you don't get any of this stuff. You can build your own. Or if you want children, you can use base component, and now everything will work. And all those problems we had with the mixing, because some people had the mixing and some people didn't have the mixing, all that is gone, because now everyone that's at least base component all have children, and it all propagates properly. So you can have a tappable inside. We also now have the draggable, so you can have all that nested inside children, and it will work out. 6, we were changing basically how the widgets work in the gestures. So as before, you had your game class, your game instance, and then you do .widget. Now you have to wrap your game in a game widget, and that is much more powerful. And basically, we're changing everything about how it goes into the Flutter widget tree. So there are lots of changes there to make it much better, much more in line with how the widget tree expects things to be. And it also revamps the whole overlay system. So the widget is overlay. So if you want to like pop up a menu dialog using Flutter widgets on top of your game, or like a menu or something, you can do all that. And we also added the draggable mixing, similar to the tappable that already exists to your components. And finally, 7, tidying it up. So this is basically cleaning things up, removing all the deprecated stuff that we had, renaming a lot of things that we never renamed because rename is a breaking change. It requires everybody to rework, like replace the name in their games. But since we're breaking a few things, we decided we want to make the API clean and simple. So we want to make sure everything is consistent and properly named. So some examples. So animation became sprite animation because we can have other types of animations like flare animation, for example. We renamed resize to onResize to be in line with the other event handlers. On the game context, the size became game size, not to be confused with the size of the component, so making things clearer. We removed the add later. Now always add later, which is actually you should even use add before. You should always use add later, so why not make it one thing? And overall, we unify names of everything so that it's consistent and clean. And yeah, those are the 7 things. Well, is there an 8th thing? Well, as I said, we're still working on V1, and there are a few things underway, but we don't think there'll be any big breaking changes anymore. So if you want to migrate your game, I think this is a good time. You might still need to do some renames once we release the actual V1, but this will be most of it. And a couple of things we also want to do is make sure our API is ready for no safety. So we already have a no safety PR being reviewed. We will, as you know, in Flutter, you have to support both for a while. So we plan to support both. But we want to make sure the API we have for V1 makes it easy to migrate to no safety. So we don't have any pitfalls in our API that when we actually go to new safety, that we'll have to change everything. And also in general, tightening it up. So after we do everything, we want to go through and make sure everything is clean and consistent, all the naming. So we've already done a lot of that in step 7, as I said, but still things might pop up. So names might change, but I don't think anything like structure-wise will change a lot anymore. And that's it. I just leave a final CTA call to action for you guys. Go check it out. Go to GitHub. You can try the develop branch if you're very adventurous. I'll wait, and we'll release the release candidate 3, and you can use that in your games. You can point it to master if you want to be a little bit safer. Yeah, try it out. V1, send us feedback. This is the time. If we want to change something, if something's not clear, if it could be better, and any kind of breaking changes, we need to do it right away, because then we'll have a very strong, solid foundation V1, and then of course we'll keep improving on top of that.
Excellent. So we are a little bit short on times, but I think we can have 1 or 2 questions. So if anyone has any question, please. No.
You can always send questions on Discord, and Eric will let me know so I can help answer. I'm sure there'll be a lot of questions about V1 in general, and this is not the focus of the event, so I think we can move forward and have a very interesting talk about a very cool game that I've been playing that I'm really excited about.
Yes. All right. Thank you a lot, Lua. I'm gonna bring David here, and awesome. All right. So we are ready for the next presentation. So David is the developer of a very, very awesome game called Toad. Maybe some of you guys have saw it. It was recently released, right? And
yeah, right before mid-November it was released. Do you mind if can I post in the comments? I can't, can I?
Sure, feel free. I have my own copy of Toad here.
Here it is.
On my tablet, and it's really, really cool game. It's very hard, but it's really, really cool. All right, so I'll leave the stage to you, Dave. The stage is all yours, and if you need anything, just call me.
Oh, cool. So I'm trying to. I can't seem to add comments. I was going to add links to the game in the comments.
Yeah, I can link the gaming link on the chat. Leave it to me.
So anyone wants to check it out, support is greatly appreciated.
Yep.
All right, so those of you who have seen Tomb Toad around know it has a rather interesting kind of 3D effect. And I'm going to kind of go through the conceptual process of how that was developed. It ends up being a little more complicated than it seems on the surface. A lot of that has to do with sorting issues and getting things to rotate and stay lined up correctly. Sorry, switching screens. Can you all see my code here? So let's start with, this is what I'm going to be showing here. I'll show the end result first, and then I'll step back and kind of step through the code. I have my cheat sheet here with all the steps. And I should note that this particular presentation is using an older version of Flutter and Flame, simply so that I can display it as a Mac OS app. It's just a little easier for my setup for streaming. So this is what the final result's going to be. You can see you have this nice.
Sorry, Dave, have you shared the screen? I can.
Oh, am I not sharing?
I
I'm sorry. Let's try that.
Oh, there you go.
Thanks, Eric.
Yeah, no problem. All right.
All right, there we go. Now you can see this is what the final result's going to be. This nice kind of 3D looking wall that can be rotated. So let's step back here and just start from the beginning. Anyway, like I was saying, I'm using an older version of Flutter and Flame, so there's a couple things that are going to be different. All right, so let's just start here. Just drawing a simple square. You can see I have 4 corners, drawing a path between them. This is basic Flutter drawing API here. From there, we will add, so you can see the square is not centered, and we want to rotate as well. So let's do that. So the things I added here, this is going to be key. I add this update rotation function, which creates a matrix. And that's going to be key because that's a nice way to bundle up position and rotation together. So what this does is it will reset the matrix, your transform matrix, rotate it, and then this translate repositions it into the center of the screen. Well, I shouldn't say that. This actually resets it to 0, and then up here, during my update, my 4 corners of the square, I'm applying that matrix to each corner, and then re-adding in my translation. And I can demonstrate why I do it in that order here in a second. So now if I refresh, we have a nice rotating centered square. So if you want to see, if I comment those out, as you know, everything in computer screen space starts with 0 at the top left corner. So without the translation, you can see our square rotates from the top left corner, which is not what we want. Now, if we just do this part and reset the matrix so it's positioned at 0, it's now rotating in the center of the square, but it's positioned still at the top left of the widget. So that's why we do these in that order. Now we're back centered. All right, so that's the core of how a lot of this is going to work, is that matrix function. Now we're going to go in and we're going to add some tiles. Now again, I'm using this is based on a very older version of Flame. In the way this is processed, I'm not using the built-in sprite. I kind of have my own custom, I call it a tile, but it's a sprite, and it basically has a render function in here. So you can see up here, I'm adding all these tiles, just hard coding them for now. This is what my tile sheet looks like. And for now, I'm just going to be using this top left single square here. And then the only thing I really do is I add this loop to render them every frame. So now if we restart, now we have a little square of tiles. And so from there, I know they were just talking about the new Vector 2 class added to Flame. One issue is that a matrix requires math of a Vector 3 or a Vector 4, so Vector 2s don't necessarily work. But that's neither here nor there. So from here, let's you can see this are my little grid of squares here isn't scaled properly, it's not positioned properly, and it's not rotating at all. So let's go to the next step I have here, which we'll just do a simple add the scale in. And to do that, you can see my little update in my game function here. Now for each tile, I'm taking its, so I have to update its position and its scale. And the way I do that is each tile I have a set, this little set transforms method where I can pass in an angle, a scale, and a position. This isn't the actual final implementation that was used in Tomb Toad at all. It's just kind of simplified for get the point across for this presentation. So basically I take each tile's coordinates, which is on a grid. So from the top left, you have 0, 1, 2, 3, 4, right? And then I multiply it by some math to get it to scale properly with the screen. And then down here, rather than in my render function, rather than translating just its coordinates, I have a special screen position. And then I scale the canvas to make them the right size. So let's do that. And there we go. Now they're scaled properly and positioned properly on the screen, but they're still not aligned with that transform matrix. So they're not positioned with the square and they're not rotating with the square yet. So next, originally, if you remember, I did this quick step where each of the corners of the square I applied to matrix and added this modifier to recenter it on the screen. So I'm just going to do that exact same process to each of the tiles up here in this. So not those two, these two lines. So apply matrix and then add that modifier to recenter on the screen. And then down here, the only addition I did was I'm now rotating the canvas when I draw each tile. So when I redo that, there, now we have tiles that are properly centered and rotating as we want them to. All right, so next step is kind of just a procedural one. You can see that you know, each tile is just this square, but on my tile sheet I have a bunch of various tiles, so you know, the wall will actually look like a wall. So if we do, and that just, if you look up here, each tile has a, you know, source rectangle, which is where it's pulling from the tile image. So if we save that and reload it, there, now it looks like an actual wall with grid tiles that are lined up. All right, so we got the matrix stuff done, and it kind of looks like a wall. So this is going to go a lot quicker than I thought it was. But next is where the magic really happens here. So if you remember in the beginning, we want that 3D effect. And the way I was able to do that is simply, so we have, you know, these drawing nicely, and they can rotate with the level as the level turns. And basically, you're going to draw this same scene multiple times and shift it up on the screen's y-axis, so up towards the top of the screen on each iteration. And it's really that's the core of it. But you'll see in a second that it introduces some problems, which is why I have to kind of structure it the way I did. So things I added here, you can say each tile now has a number of layers, a separation value, and that's really it, I think. So now, every time I draw, I translate it, I subtract the separation times the scale times, whatever iteration I'm on. So let's just start with 2 here. And when I save it and reload it, you'll see it'll stack. Now it's drawing a stack of 2 there. Ooh, but there's this weird sorting issue, which I'll get to in a second. If I set this to 3, reload, now we're drawing 3. And that's really the, we got the 3D effect working. But we still have this weird sorting issue. And this, again, comes to why some of you may be wondering why I'm drawing. For each individual tile, I'm doing a translate, scale, and rotate. It seems intuitive that you should be able to scale and rotate the whole canvas first and then draw each tile in there. But because of issues like this, I haven't found a way to get it to work. I will be posting, by the way, when I'm done here, I will post this GitHub link. So you all can go in and tinker around. Maybe you guys can find a better way to make this work. But so far, for these tiles, I found it's best to draw each individual tile separately and not try to really batch them in terms of canvas transforms. So, sorting issue is the next one. So now, go up here, back into my game code. Really, the only thing added here is this. So now I'm taking after I've applied the matrix, so each tile now knows where its screen space is supposed to be, or its screen position. I'm now just doing a simple sort by screen position Y. And for this particular case, that works fine. Once you start adding sprites, which act as billboards rather than this rotation effect, things get a lot more complicated. Maybe I can talk about that later, but for now. So now if I refresh, now you'll see everything stays nice and sorted properly. It looks nice and clean. And now we're almost done. There's a couple final touches. Really just one thing. So you go in here and just stop it from spinning for a second. You can see the tiles all line up, like the bricks all line up, and that just doesn't, that looks messy. It doesn't look right. So I have added this little bit of code. Basically, instead of having a source frame, now every tile has a list of source frames that it will use for each layer. So down here, you can now see my draw image call is stepping through the source frames with each layer as well. And that looks like, I'll turn off rotation so you can see it. Reload. There, now they look like bricks. Cool. And then if I put that back to make it spin, you can see the full thing spinning in full 3D, which is pretty cool. That was pretty fast. That was only about, what was that, 10 or 15 minutes? I mean, that's really the core of what I wanted to show you guys. I can explain real quick. Once you start trying to add sprites, like in Tomb Toad, we have the sprite of the little toad that moves around. Now, if you try to think of this in 3D space, you want that toad to kind of be standing up as a billboard versus these walls, which are laying flat on the floor, versus the toad, which is kind of standing up like this. since it's, we don't have access to like a per pixel depth buffer or anything to sort that way. I actually created a kind of pseudo 3D camera, which really amounted to no more than a position, which roughly, it was just a vector 3 that roughly aligned to about where the camera would be from this view, and then did rather than a sort by screen position Y, I actually did a sort by distance to that camera position. It's mostly works for the bigger characters, like some of the bosses in that game. Doesn't work so well, but yeah, it's well enough. So that's really it. I'm gonna stop screen sharing for now. So if anyone has any questions from there, here, let me share the repo. Still not able to. Still not able to add in the comments, but I'll see if someone else can do that.
Sure. I'm gonna also add the links, all the links to GitHub and of the repositories on the video description. So
yeah, I expected that to be more like 20-some minutes, but that was a little quicker than I thought.
Oh, that is very interesting. This 3D stuff is very, very interesting to me.
Thanks. Yeah, it's a bit more, like I said, more of a conceptual thing of how kind of I had to build it up, rather than, honestly, there's not a lot of Flame code in this presentation. I created my own game extension and then built a bunch of stuff on top of that, but that's about it.
Yeah. We have read one question.
Sure.
How did you do the collision detection? Was there anything that you had to think about?
Yeah, so collision detections, there's a lot of issues there because visually, I'm using 2D sprites, so visually things aren't in the same place as they appear on the screen. So for example, when you're looking at that little spinning 3D world, your brain automatically tries to turn that into a 3D world. So now you stick a little guy in there, and sometimes you expect the collision detection to be, like a little circle around his feet. But then at other times, you expect it to be a circle in screen space around the whole sprite. So there's definitely a lot of gray area with the collision. The walls are easy because they're just squares, right? And they're axis aligned. I know the screen's rotating, but you can just undo that when you're doing the collisions. Yeah, collisions got very complicated. I ended up, most of the sprites in Tomb Toad actually used circular collision because it was just impossible to make square collisions work and not have you always clipping little corners of a square collision box as you went by something. You know what I mean? Like if you have like a little fire sprite and you have a square collision, there's going to be these corners sticking out, and players hit those and they didn't even touch the actual graphic of the sprite. But they clipped that corner, and yeah, it's very complicated.
I can imagine. Awesome. Anyone has any more questions? All right. I think that's it. It was very, very interesting presentation. Thanks a lot for that. It's really cool to see how that awesome effect on Tomb Toad was created, and thank you a lot for the presentation.
You're welcome. Thanks for having me.
All right, let me call the team back to the stream so we can end the event. So, all right. Thank you everyone that helped to make this event possible. It's really cool to be able to have this community and to do these events and to see awesome things that people create with it. I still find it very amazing to see all the games that Lua is showing off his awesome. Yeah, I don't have one yet. Anyway,
Where can I get one of those?
yeah, we do have a site that you can buy those mercs. I'm gonna plug the link on the chat eventually.
Mugs.
Yeah, but that's it. That's it. Anyone 13 wants to say anything? That's the time.
Thanks for moderating. And I think you probably had to pull in and out my screens a lot of times.
Yeah, it was very challenging. All right, so I think that's it for this edition of FlameCon. Thanks a lot for everyone that watched, that helped us to make this event, and we see you all on the next edition.
And on
Bye-bye.
Discord, hopefully.
Yeah.
Thanks, everyone. This was really great.
Until next time.
Thank you. Bye-bye.
See ya.
Have a good